Okay, given that P is a real number, this statement, and they ask me to find the values of the P. In order to solve the second part, I am going to take this W and then replace here. So let's look at some prerequisite knowledge now. What is argument of Z? Argument of Z can be expressed as tangent inverse, the imaginary over real. So usually you write the Z as X plus YI, right? So the imaginary part is the Y and then the real part is the X. So you will be writing tangent inverse Y over X. It's depending on what you have. Now in our question, it is argument 2 plus P plus 4I. If you solve the middle part, this is what you will get. I know that I can express this as tangent inverse imaginary, which is the 4, and then a 2 plus P. Okay, so this is the first idea. Now second idea is how to get rid of your tangent inverse. If you take your calculator and then you type tangent inverse pi over 4, you will realize that the calculator is actually giving you pi over 4. So the idea is maybe a sine and then sine inverse x. It will give out x. You can put any value for the x and you can try it in the calculator. So this is another tips you need to know in order to solve this problem. So let's begin solving now. You can try. So I'm going to write the middle part is tangent inverse 4 over 2 plus P and then 3 pi over 4 pi over 4. So how do I get rid of the tangent inverse in the middle? I have to multiply everything, the left, the middle and the right with tangent function itself. So that's going to leave me with tangent pi over 4 over 2 plus P and then tangent 3 pi over 4. The left and the right you can substitute into your calculator and you can rewrite your answer as 1 to negative 1. So even when I say it sounds very odd, nobody says 1 to negative 1. You have to write the smaller number on the left hand side and the bigger number on the right hand side. So you rearrange accordingly. You do negative 1 to 1. Your aim is the P. So how do I do this very fast? I can just drag the 4 down. So 2 plus P (4) and then negative 4, and my P value is 2 and negative 6. See, these are the possible values where if I put the P inside, then my angle is going to be in between 45 degree to 135 degree. Now let's look at the third part here. The third part says the complex conjugate of W is given by W asterisk. I think you already know. So let's write first. What is conjugate? And what is the answer for this particular conjugate? W is 2 plus 4i. So conjugate of W 2 minus 4i. I think everybody knows this. Now they say it is being represented in an Argand diagram. You're going to draw it in an Argand diagram where W is point S and the conjugate is labeled as point T. So how do I write this? So this is going to be my S. My S is 2 comma 4 because it's a point. It's not a complex number. Then the conjugate is T and we're going to write it as T comma negative 4. Find in the form, this form here, equation of circle passes through S, T and the origin. So let's try to illustrate how it actually going to look like. I'm going to draw this. I'm going to have 2 here and then there is a 4 and this is my point S. Same way it is symmetrical now, negative 4 down here, then I have a T and I also have a origin now. So my circle is going to pass through, and then when I looked at this part, indeed it is a circle. I need to look for my radius, which is a K, and then I need to find the center. The center is the A, the radius is the K. So let's try to make a basic sketch. I don't know, Chinchai first. Of course it is wrong. Yeah, something like this. Even when I draw this, you know that the center has to be somewhere here. Do you agree? Right? How are we going to find this center? The center is A given there, and then now this part here is your radius, which is the K. Okay, so let's just write it as K. I follow the question, I'm going to write it as K. If center to S is K, what is center to origin? Also K, right? Okay, good. Then what is this length? If all of them is equals to K, now I only want the green part. Can I label that as K minus 2? Okay, and I know that this is definitely 2 because the coordinate here is 2 and then a 4 like that. See? So they look perpendicular to each another. When the radius touches here, and then this length and this length is going to be same. When I merge, definitely this is 90 degree. So the moment I see 90 degree, I'm very happy with my diagram. Why? Because you can use Pythagoras theorem. So let's just write that. I know that this length is 4. So 4 squared plus K minus 2 squared, it's exactly equal to K squared. Simple. Then let's expand. You get 16, 4K plus 4 equal to 0. I'm doing fast, so I think you understand. So K is going to be equal to 5. What is K? Exactly my radius. Okay, one problem is done. I know my radius. Do you think I can find what is my center? What is this gap here now? What is this gap? This part here, what is the gap? It is exactly K minus 2, which is 3. So the length in here is 3, this is 2. So from the origin, how much are you traveling in order to go to your center? 5, right? So the center is definitely 5, 0. Therefore, your final answer is modulus z minus 5 equal